here with a very new problem, and the problem name is construct a string from a binary tree. So let's see the problem and then see how we can solve it. So in this problem we have a root of a binary tree and we have to construct a string which consists of parentheses and the integers. Integer is nothing but the value within the binary tree, and we have to traverse the binary tree in the pre-order form. Okay. And what are the other things? If let's suppose there is any empty parentheses we find which don't map the one-to-one mapping, okay, like the string mapping with binary tree, so we can omit this, we can basically remove that. What it actually means, let's understand. So first of all, this is a binary tree we have, and we have to traverse this binary tree in the pre-order fashion. In pre-order means first we have to traverse root, then we have to traverse left subtree, and then we have to traverse the right subtree. That is nothing but a pre-order traversal of a binary tree. In that case, we have to traverse it and create a string by traversing this, and also we have to omit all the empty parentheses which is not mapping with the binary tree. What does it mean? Let's understand this. If we try to traverse this, we have one first, and then we have a parenthesis, then we go to the left side, and then we find 2, and then we again go to the left side, then we again have 4, and if we try to move left side, there is nothing. In that case, we have to close this parenthesis. Now we come back and we can see that there is nothing right. In that case, we don't have to add empty space, because if we add an empty space, it doesn't make sense because there is no right subtree. In that case, we can simply make another close parenthesis such that this subtree is traversed. Then we go back, and after go back, we have to traverse the right side of binary tree. When we have to traverse the right side of binary tree, we have to open one more parenthesis and write 3. And now you can see this 3 is nothing but a leaf node. There is no left and there is no right. In that case, we can simply close it and we have this answer. To understand one more edge case, I have one more example. Let's traverse this and find out the solution from this. In that case, again we have root 1, and then we have to traverse the left subtree, which is 2, and now you can see there is no left subtree of 2, but there is a right subtree. If I don't, let's suppose if I don't add empty parentheses and I directly add this 4, then from this string we are not able to map, or we can't understand that this 4 is left subtree of this 2 or it is a right subtree. That's why in case for a root node, for a node, if there is no left subtree but there is a right subtree, in that case we have to add an empty parenthesis such that we can understand for this node too there is no left subtree but there is a right subtree. And once we have to traverse the right subtree, we open one more parenthesis, add 4, and that's how we return back. When we return back, we add one more closing bracket so that we traverse the whole left subtree. Now we are entering the right subtree. In that case, we open the parenthesis, and once we reach here, we find that it is a leaf node, and for a leaf node we only have to do closing bracket, and that's how we build this. So from this you can understand some point. The first point is, if we are traversing the right side or if we are traversing the left side, and if both is present, it means for a node the right node is also there and left node is also there. In that case, before traversing it, we have to append a parenthesis, right? The other case we find is for a node, if there is no left subtree. So let's suppose left subtree is not there but right subtree is there. In that case, what we have to do, we have to make a empty parenthesis such that we understand that there is no left. The other part is If there is no right subtree, in that case we don't have to do anything, right? What is the last case we understand? For a leaf node. So let's suppose there is a node and that node is a leaf node. In that case, we only have to close the parenthesis. So in this code, as we discuss the point, I have to go from down. So basically, I have what I do. I basically have a string, okay, and I first put the root value within that, and this is an integer value. So that's why I'm doing a data type. Type conversion, and now I am calling my function. In this function there is a very basic case. If root is none, we have to return from that point, and in the other case, if there is a left part of the root, what we have to do? First we have to open the parenthesis and push the value, whatever the left value we have, and then we have to call the left side, right? And once we iterate all the left subtree, when we come back, we have to close this also. Okay, this is the case when we have left, and similar case for right. If there is a right, we have to open it, we have to push the right value, call the next right part of the node, and once we complete the right subtree, we have to close it. And there is one extra case. In that case, if the node left is not present and it is not also a leaf node. So what I mean is, if you see this one example, so you can see that for this node there is no left subtree, there is no left node, and also it is not a leaf node. In that case, what we have to do, we have to add an empty open closing parenthesis, and that's how we are building this string from this binary tree. I hope you like this problem, and thank you.